Welcome to this explainer, where we're going to completely decode Cambridge IGCSE Mathematics, specifically focusing on those tricky geometric transformations and spatial reasoning puzzles. I'm thrilled to be guiding you through this today. We're going to take some seemingly straightforward math problems from our 0580 syllabus and literally pull them apart to see what makes them tick. Whether you're a student aiming to boost your grade boundary or just someone who loves a good logical challenge, you are absolutely in the right place. Before we get into the heavy lifting, I want you to visualize this spatial puzzle in your head, because it's exactly the kind of concrete problem examiners love to test. Imagine a standard Rubik's Cube. Now, dip it entirely in a bucket of paint, let it dry, and shatter it into its individual little blocks. How many of those tiny blocks would have exactly two faces covered in paint? Keep that image locked in your mind. Here's our investigation blueprint for today. 1. 2D transformations. 2. The painted cube puzzle. 3. Scaling up the cube. 4. Generalizing the formula. And finally, 5. The triangle count challenge. Let's kick things off with Section 1, 2D transformations. Okay, so the crucial point here is that shapes often undergo a sequence of movements. It acts like a multi-step mathematical journey rather than just a single simple jump. In standard geometry, we learn about the basics, right? Translations, rotations, reflections, enlargements. But advanced investigations push us further. They ask us, what happens when we chain these together? It literally forces our brains to hold one transformed image in our working memory and then apply a completely new rule to it. It's a fantastic mental workout. Let's look at this example. We start with a simple triangle, ABC. Step 1 tells us to map it to a new triangle via an enlargement with a scale factor of 3, originating from the center coordinates 0, 7. So we've basically blown the triangle up to 3 times its size and pushed it away from that center point. But wait, we aren't done. Step 2 takes that new, larger triangle and reflects it across the vertical line where x equals 1. You have to map that intermediate step perfectly, or your final destination will be completely off. And hey, before we continue, subscribe to our YouTube channel Ace the Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now. The difficulty really ramps up with combinations like these. Take the first one. You reflect a square across a horizontal line y equals 3, and then you have to pin it at the coordinates -2, 5, and spin it 90 degrees clockwise. Or look at the second one, enlarging a rectangle with a scale factor of -2. A negative scale factor doesn't just change the size, it flips the shape entirely through the center of enlargement. After those mental gymnastics, you then reflect it across a diagonal line. Mastering these steps sequentially is an absolute game changer for your spatial reasoning. Moving right along to Section 2, the painted cube puzzle. Consider a solid 3 by 3 by 3 centimeter cube, completely painted on the outside. Every single face of the large cube is dripping in fresh paint. We then slice this large cube up into 27 individual 1 centimeter cubes. This is exactly the scenario I asked you to picture at the very beginning of our session. Now, we've got a pile of 27 tiny blocks, and we need to figure out exactly where the paint landed. We can actually categorize these 27 tiny cubes into 4 very distinct types based on how many painted faces they have. Let's call them types A, B, C, and D. Type A cubes have 3 painted faces. If you think about the structure of a cube, where do 3 faces actually meet? Right at the corners. Type B cubes have 2 painted faces. Those sit right along the edges between the corners. Type C cubes have just 1 painted face, meaning they are flat in the dead center of the larger cube's outer faces. And finally, type D cubes have 0 painted faces. They were hidden deep inside the core of the big cube, completely protected from the paint. Now let's tackle Section 3, scaling up the cube. So what if we swap out our 3 by 3 by 3 cube for a 4 by 4 by 4, or even a massive 10 by 10 by 10 cube? How does the distribution of our 4 types of painted cubes shift? Think about it. The number of corners on a cube never changes, no matter how big it gets. But the number of edge pieces, the size of those flat-faced centers, the volume of the hidden core, those numbers are going to absolutely explode. And before we solve this, stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions.
To tackle this, we can set up a structured data table to track our findings as we count the varying cube types across increasingly larger volumes. By systematically calculating the numbers for the 3 by 3 by 3, then the 4 by 4 by 4, and jumping to the 10 by 10 by 10, we aren't just doing busy work. We're generating a data set. And in mathematics, a beautifully organized data set is the runway that allows you to take off into higher-level algebra. And that brings us to Section 4, generalizing the formula.
The ultimate goal here is to discover a universal formula that works for any hypothetical cube that is n by n by n units in size. This is where you find the true elegance in the math. For example, if you realize the unpainted type D cubes are just a smaller cube hidden inside, you might deduce that its dimensions are simply the total widths minus the two outer layers. So for an n by n cube, the number of unpainted blocks is simply n minus 2, all cubed. By finding formulas for A, B, C, and D, you essentially crack the code of the cube forever. And this perfectly illustrates the power of top-tier exam strategy. Once you conquer the perfect cube, you are challenged to adapt those formulas for an irregular cuboid with varying lengths, widths, and heights. It forces you to deconstruct your earlier formulas, because now the length of your edges and the areas of your faces aren't all uniform. A formula that relied on everything being identical now has to account for 3 entirely different variables. It's a fantastic test of whether you truly understood the underlying geometry or if you just memorized a pattern.
Let's wrap things up with Section 5, the Triangle Count Challenge.
Picture a single isosceles triangle. Now, imagine a vertical line sliced right down the middle, from the top apex down to the bottom base. This creates exactly 3 distinct triangles in total. You have the smaller right triangle on the left side of the line, the smaller right triangle on the right side of the line, and of course, the large original isosceles triangle encompassing both of them. 1 line, 3 triangles. Seems easy enough, right? But here is where the investigation truly begins. If one vertical line creates 3 triangles, what hidden mathematical pattern dictates the total number if we draw 2, 3, or n vertical lines? It's not just a simple multiple, right? Because the triangles start overlapping and combining to form larger internal ones. So I'm going to leave you with this provocative final thought to investigate on your own. Grab some paper, draw a triangle, track the data, and uncover the algebraic secret hiding in plain sight. Students who implement these mathematics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at @acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by. Drop a comment below with your target grade for mathematics and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.